In response to expanding on the data types signed and unsigned values, how are we going to get the information from a raw stream to understanding what it should be in some manner or form or fashion? And for that, I usually reference people to a site called Crypty. I already have mine pulled up. I've already got it set up, for instance, here. If you ever get to this site and you need to understand, first you want to view the bytes in typically hexadecimal format or binary. We can do it both ways. You can group. You want to group by byte. You want to encode as an integer in a decimal level. We'll start with 8-bit and we'll work our way to 16-bit. And I won't get to 32-bit. If you can understand 16-bit, you can understand 32. And then we can see the text, and it does this live. So you can see that this is an 8-bit unsigned value. We have all zeros here on the base 2, all zeros with a 1 for the second byte, and then all ones for the third byte. And you can see that, let me go back to hexadecimal. We have 00, 01, and FF. That gives us a value of 0, 1, and 255 in decimal form. If I was to click signed, now we see an 8-bit signed value, 0, 1, FF. And I'm going to swap these around a little bit to make it a little bit easier to understand. 0100 FF. So if you were to roll, if you're rolling these values, you would see like the value below 00 be FF. Just like when you were rolling from the other way around, if you got all the way to FF or 255, it rolls back to 0. And that's the condition between signed and unsigned. Now, the easiest way to explain it, binary, is this first bit here is a kind of your signed bit. So I'm going to change that to a 1. And now it's negative 127, right? Because it's negative and then it's going down the scale until we can get the 1. So there's negative 128. And then if you were incrementing this value, it would be like 0111 1111, right? Well, we're rolling over by doing so. See how we go to 127? So it goes from the bottom back up to the top, and now we would work our way down. So that is how the signed and unsigned situation plays out. It's 7E. Once you get to 7F, there's your last signed value. 80, negative 128. So it would be 128 positive. It goes negative because the first bit, the most significant bit in that, is a 1. All right, so I'm going to delete one of these. We're gonna get rid of it to make it easier to understand. We're going to go to 16-bit unsigned, okay? And we're going to type in, so right now we have a binary value of 10000000 or 8,000 in hex. And the Indian's big Indian. So what that means is we're calculating first this one and then this one. So we end up with a value of 32,768. And if I was to put a 1 here, you get 32,769, right? Okay. So essentially, the difference between big Indian and little Indian is Motorola or Intel is how it references, which byte does it reference first. So I click little Indian, our number changes drastically because we're referencing this byte first and then rolling over to this byte. So in order to get that 32,768 value again, it would have to be like so. And that's for a 16-bit unsigned value. So if you go to binary, you can see that it's 32,768. Our bits, that's our least significant bit. We roll it over, and then we come from here and we roll it all the way to the top. We go big Indian. We're starting here. We're rolling it over, and then we just jump over across and keep going. Big Indian is what I prefer. It makes things easier to look at because if you're looking things at a bit scale, it just keeps going linearly. But it really doesn't matter anymore to me. It's just convenient if you look at things in binary format, which I do. All right, so 16-bit signed. right? So so since we're looking at this in big endian, this is our sign bit here. So if I go 1, now we got negative 32,640. And it goes all the way back to, so there's our negative 1. Bring that number down, negative 2, negative 3. It's just working its way down the scale. And you got to remember that the byte order is still big endian, so it is this most significant bit here that is the sign value. So if I was to put that as 0, we get 32,767. 1, negative 1. 65,535. 32,767. Because it's not looking at it as a signage value. And then go back to signed. We'll get a negative 1. I'll change the byte order. Now this is one number because all the bits are the same value. That it's not going to change based on if you're big endian or little endian. I just bring that to bear in mind that there is some values that overlap, as you're well aware of with most of the positive numbers that they have, with all the positive numbers that they have that fall within both realms. There is negative numbers that fall in both realms too, this being the only one. But so if you go little endian, right, it starts here and works its way across and goes all the way across to the most significant bit there. So there's our most significant bit denoting the positive or negative value. And if you have any more questions about this, feel free to come to this site and set it up. You'll probably, if you come to it, let me see, we'll just go. You'll probably end up with, yeah, you'll end up with this right here, which is just, you know, mayhem. So if you reference this right here, so view bytes, encode integer decimal, view text. So view bytes, and leave it hex, encode integer decimal. We'll remove this one, view text. Okay, so I'll take all this off. We'll go to 8-bit unsigned. We'll go 00, 01. Oh, don't hit tab. 01, 02. Yeah. And this will get you all the information that you need when you're looking to say, hey, I need to know what this hex value really is in decimal form. Or you can go vice versa. You can change it up. So you can type in, like, you know, 255, you know, 254, or if I put it in tab, 254, you know, and you know, I don't know what it'll do if you, let's try negative 1. So it references it, but it's not really an unsigned value. So it's like, it would throw an argument in my opinion, but negative 1 looks like FF to this, even though it's considered unsigned. So anyways, I hope this helps. If you have any questions, feel free to leave them in the comments.